Students, in this video, as you are observing on board, we are going to discuss about electric circuit and its component. First, we are going to discuss about quantity of charge. What is the meaning of quantity of charge? What is the meaning of quantity of charge? The number of electrons flow through a cross section in 1 second is known as the quantity of charge that flow through the cross section of the conductor, but it is not the exact definition. Exact definition says that number of charge or electron, the number of electron which drift from higher potential to lower potential, number of charge which drift from, use every words very carefully, from higher potential to lower potential. Higher potential to lower potential is called quantity of charge, and this is denoted by Q. This is denoted by capital letter Q. The amount of electron, amount of charge drift from higher potential to lower potential is known as quantity of charge, and this is denoted by the letter capital Q. SI unit of this is coulomb. 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 Symbol is capital C. The electric charge, this is not the about quantity of charge. This is the unit of charge. This is unit of charge is coulomb C. So what is the coulomb? Definition sometimes may ask you about define 1 coulomb. So what is 1 coulomb? 1 C or 1 coulomb? I am writing this. This is wrong spelling. It's a COU. Clear? Coulomb. What is the definition of coulomb? It is the amount of charge which, now come to the topic electrolysis, which deposit some 0.00118 gram of silver on the cathode when passed through silver nitrate solution is called 1 coulomb. Always remember that if we are discussing about 1 coulomb, this is amount of charge which deposited this amount of silver at cathode, gram silver at cathode, when electric current or that those charges passes through silver nitrate solution is called 1 coulomb. Those charges are known as your 1 coulomb. You must remember this digit. Hope this thing is clear. It has been found that 6.25 into 10 to the power 18 electrons, large number of electrons, 18 electrons pass through silver nitrate solution to produce charge of 1 coulomb. And so total number of charges, this charge, total number of electron, this number of electron produce 1 coulomb charge. So from this we can easily find out the charge of 1 electron. How we find out? Let's see. As we know from the last discussion, charge on 6.25 into 10 to the power 18 electron equals to 1 coulomb or 1 C, we can say. It's a C for coulomb, capital C is there, na? So therefore charge of on 1 electron equals to 1 upon 6.25 into 10 to the power 18. 10 to the power 18. This is the charge of electron. It's a C. So in this case, when we solve this one, it's a 1.6 into 10 to the power minus, because it moves upward, minus 19 coulomb. You must remember this one also. You must remember this digit. You must remember this figure. So move to the next topic. Now our next topic is about current or ampere. The rate of flow of charge, in an electric circuit is called electric current. So I think it's easier for you. What is electric current? It's a rate of flow of charges. A rate of flow of charge in an electric circuit is known as your electric current, and this electric current is denoted by capital I. Clear? Symbol is capital I. So if Q amount of charge flow through a conductor within a time t second, so I is equals to Q upon T, and the SI unit, it's a coulomb per second. Unit is your coulomb per second, but this is not the perfect unit. Actually, SI unit of current, SI unit of electric current is ampere. It's ampere. Symbol is capital A. It's ampere. What is the definition of this 1 ampere? So always remember, in case of 1 ampere, see here, if 1 coulomb of charge flow through an electric circuit in 1 second, is the current flowing through the circuit is known as your 1 ampere. Clear? 1 coulomb charge flow through the electric circuit in 1 second, the amount of current is known as your 1 ampere. This is the definition of 1 ampere. All of you must remember this one. Like your all the metric unit, ampere can be converted into kiloampere or milliampere also. You must read the relationship given in your book. Now there is a relationship between current, number of electrons, and electric circuit. It's as it is says that, see over here, place this side, as we know that I equals to Q upon T. Clear? Amount of charge by second T. But we also know that this Q is equals to number of electron and E minus. E minus means negative charges. If an electron flow through a circuit such that a large charge on each electron is E minus, then if this number of electron, each electron contains negative charge, n number of electron can flow, so it's n into E, and this creates the charge on the electric circuit Q. So Q, in this case, Q equals to n into E. So then we can easily write down I equals to n E inverse upon T. This is required for your higher classes, 9th and 10th. Now move to the next topic. Yes, next one is your electric cell. It's not about biological cell, it's electric cell. I have written over the complete electric cell. This is a very small source of electric current. We use this in very small devices like your torch, your watch, or everywhere. In remote control also we use these electric cells. These are of different types. Maybe button structure known as your button cell, Clear? These cells are also known as your primary source of electric current or primary cells. There are some storage cells which need some charges like inverter. We can store electric current easily in those large cells. Those are actually not cells, they are actually battery. They are storage cell. We store the charge by charging them, and then later we receive the current. Now move to the next topic. Now our next topic is your about resistance. Materials provide resistance, not materials, conductors. Current carrying conductor provides some resistance in flow of current. Then it depends upon material to material. This resistance is known, this resistance, this opposes the opposing property is known as your resistance. Once again, let's read the definition. The friction or obstruction offered to the passage of electric current by material is called resistance of material, and this resistance of material is measured in unit ohm. It's known as your ohm, having symbol looks like, see the symbol, first draw this one, then a circle, but need not to close the circle. Likewise, this is your ohm. Clear? What is the 1 ohm? The resistance offered by a conductor when a current carrying conductor, when a current of 1 ampere, current of 1 ampere flows through a conductor such that it offers a potential difference at the end is 1 volt. You must read the definition of 1 ohm. When a current of 1 ampere flow through the conductor such that the potential difference at the ends of the conductor is 1 volt, then such type of resistance is known as your 1 ohm. The exact definition says, I am reading, is 1 ohm is the resistance offered by a conductor when a current of 1 ampere flows through it such that the potential difference at its end is 1 volt. Generally, this resistance having formula V upon I, where V is a volt, I is a current, ampere, R is the resistance in ohm. So suppose in any numerical it is given to you that if a current of 3 ampere, current of 3 ampere means I is your 3 ampere, flows through a current carrying conductor whose potential difference B is 9 volt, V is 9 volt, potential difference V is 9 volt. So what is the resistance? So resistance must be, it's a V upon I. V is your 9 volt, I is your 3 ampere, means it's a 3 ohm. Clear? This one. Hope this thing is clear to you. Now move to the next topic, circuit. As you are observing on board, now we are going to discuss about symbol of electrical component. First we start from the wire. For a current carrying conducting wire, we use a straight line. This represents the conducting wire, or simply wire of the electrical circuit. Then after that we have a source of electric current. So for this, if we are using cell, we use this type of structure. This larger side represents plus, this smaller side represents negative terminal of the source of cell. This is no the unit of symbol of cell. Clear? Then if some resistance is there, then we use this type of symbol. This is for resistance. Hope this thing is clear to you. These symbols you can easily see. Then if there is a collection of cell, means if there is a collection of cell, that is your battery, then we use this type of structure, that this is for one cell, this is for other cell, negative terminal of first cell attached with the positive terminal of the second cell, likewise in case of third cell, and then so on. All together we have plus sign and minus terminal. Clear? Then if three or more cells arranged in a parallel way, so we use this type of structure. Likewise, no? Now then after we have a switches. These are for combination of cells. All these two are combination of cells of battery. Both this one and this one. Now then we have a switch. This symbol is for open switch, means no current can flow from the circuit. It's an open switch, and if we have this type of current, this is your closed switch. This is your closed switch. Now next we are using bulb. So you can use bulb, this symbol. This is your bulbs. If you want to more, then you can circle it. This is a symbol of bulb. Or this is the wire which attached with the circuit wire. So these are the components of electrical components. Move to the next about circuit.